Hello everyone, my name is Zhang Shuhan, and today I will introduce the method that I use to solve the question 1 on homework 6. So on questions 1, we have the xy, the joint density functions, which is here, and we also have the region of x and y. So the first question is to find a so that the above definition is a valid joint density functions. So according to the definition of joint density functions, the integral of the fxy should be equals to 1. And then we apply the up boundary and the lower boundary, which is equals to 1 and minus 1 respectively. So after that, we can calculate a equals to 4 if xy is a valid joint density functions. So the second question is to justify whether x and y should be uncorrelated or correlated. So first we look at the definition of correlated, which is the expectation of xy should be the multiply of each other. So we apply the definition of explanation, which is multiple xy to the density functions and do the double integral to these functions, and we can calculate that the final result of the expectation of xy should be 1/9, and then we should also calculate the individual expectation of x and y, and also we apply the equation of expectation, and we got the expectation of x equals to 0 and the expectation of y also equals to 0. So we can easily find that ex times ey is not equals to expectation of xy. So xy are not correlated. So the third question is to justify that xy should be independent or not. And this is pretty easy because we have the result from question 2, because xy are not correlated. So xy is also not independent, because the independent is a strong constraint according to correlated. And the fourth question is to find the joint density of x square and y square. Now we need to let big Z equals to x square and big W equals to y square. And then we should calculate the Jacob matrix, which is equals to 4 times xy. And then we need to find the roots of xy with the respectively of small x and y. So x has 2 values and y has 2 values, so we will have 4 root pairs, which is equals to this. And then we will apply these 4 pairs to the functions, to the equations, to find the joint density of x square and y square. And we just apply these 4 roots into each part and divided the abstract value of Jacob functions, which is 4 times square root of z and times square root of w. And then we calculate these functions, and the result should be 1/4 times z to the power of 1/2 and times the square root of w. And the valid region of this joint functions should be x smaller than 1, larger than 0, and w is similar to z, because z is x square and y, yes, z is equals to x square and w equals to y square, and also x is small. The abstract of x is smaller than 1, so the region of z should be less than 1 and larger than 0, then similar to the w. And finally, we need to prove or disprove that x square and y square are independent. So according to the result from the question 4, we have the distribution functions equals to this, and then we need to calculate the distribution functions of z and w respectively, and this is apply integral to z. To w, we got the distribution function of z, and apply integral to z, we have the distribution functions of w, and we got these two distribution functions, and we can easily find that the product of the two distributions equals to the joint distribution functions, so x square and y square are independent. That's all. Thank you.